Welcome back to today's video lesson on Chemistry Made Easy with Bright Edu. In today's video lesson, I'll be teaching on how to determine the oxidation number of a particular element in a given compound. Now, to do this, we are to take note of 7 important rules. The 7 important rules will guide us in order to be able to determine the oxidation number of elements in a given compound. So the first of the rules we'll be discussing now is this. So it must be noted that the oxidation number. Now, in the course of this video, I'll be using the acronym ON in the place of oxidation number. So the oxidation number of a free element, that's rule number 1. The oxidation number of a free element. What is a free element? A free element is simply an uncombined element. Uncombined element means that this element does not contain any other element attached. So a free element is simply an uncombined element. That is what we call a free element. So the oxidation number of a free element, which is an uncombined element, is 0. So this must be noted. The oxidation number of a free element, which is an uncombined element, is 0. So whenever we see a free element or an uncombined element, what becomes the oxidation number? It is 0. So let's take an example. For instance, a particular question says, determine the oxidation number of sulfur in S8. Now, sulfur as an element exists in this form as its molecule. Recall, it must be noted that for we to get a molecule of an element, we need various atoms. Now, what am I trying to say? Now, let's say this is sulfur as an element. Now, this is sulfur as an element. Now, for we to get the molecular form of sulfur, which is S8 now, we need 8 atoms of sulfur. 8 atoms. You know, sulfur has a crown shape, okay? But we need 8 atoms of sulfur. So S, like that. Combining them together, we get S8. So this is a molecular form of sulfur, and it is an element, and it is a free element because it's without a charge. So the question now is, determine the oxidation number of sulfur in S8. What becomes the oxidation number of sulfur in S8? From my explanation, the oxidation number of a free element, which is an uncombined element, is 0. So the answer becomes the oxidation number of sulfur in S8 is 0. So oxidation number of sulfur in S8 is equal to 0 because we said that whenever we have a free element which is an uncombined element is 0. So let's take another question. So determine the oxidation number of oxygen in O2. Now, looking at O2, is it the atomic form of oxygen? No, it is the molecular form of oxygen. Recall I said for we to get a molecule, we need many atoms. Okay, but in this case, we had O2. So how many atoms of oxygen formed the molecule of oxygen, which is O2 now? It is just 2 atoms, okay? O bonding to O. So you can see how molecules are being formed. So the question now is, determine the oxidation number of oxygen in O2. Very easy. The answer becomes the oxidation number of oxygen, which is a free element, in O2, which is in the molecular form, is equal to 0. That is something you must know. This is a very, very important aspect. So let's quickly move over to the second rule under determining the oxidation number of elements in a given compound. Now, in this case now, it is just that free element. So let's quickly move over to the second rule. The second rule says the oxidation number of a simple ion. The oxidation number of a simple ion. Recall, ions are of 2 types. We have positively charged ion and negatively charged ion. Positively charged ion, they are called cations, and negatively charged ions, they are called anion. So the rule now is now saying the oxidation number of a simple ion, either a cation or an anion, is the charge of that ion. So the oxidation number of a simple ion is the charge of that ion. So for instance, now a particular ion that is positively charged here was like +1 in that particular ion, which I'll be solving now. So what becomes the oxidation number of that ion? It is +1. So if here was -1, the oxidation number of that ion is -1. So if here was +2, the oxidation number becomes +2. And if here was -2, the oxidation number becomes -2. So let's take an example. Let's say the question now is determine the oxidation number of let's say sodium in Na+1. This is sodium ion. So what becomes the oxidation number of sodium in this? It is very easy. The answer is simply the charge of that particular ion, and the charge of this sodium ion is +1. So the oxidation number of sodium here, the oxidation number of sodium in Na+1 is equal to +1. Okay, because I'm saying now that the oxidation number of a simple ion is the charge of that ion. So let's say this is sodium, and what becomes the oxidation number of sodium here? It is +1 because that is the charge of the ion. So let's take another example. Determine the oxidation number of aluminum in Al3+. So what becomes the answer? It is simply the charge of the ion. So it becomes the oxidation number of oxidation number of sodium in that's oxidation number of aluminum now in Al3+ is equal to +3. Always write their signs. Be very specific with the sign. Okay, don't just write 3 like that. You have to be specific. You write +3 +1. So let's say we're having a negatively charged ion. So let's solve for the last question under this aspect. So determine the oxidation number of let's say oxygen in O2-. Okay, so what becomes your answer? It is simply the charge of this element here, which is oxygen, and the charge is -2. So the oxidation number of oxygen in O2- is -2. Okay, because the charge here is -2. So you can see how questions like this are being tackled. So this we've discussed about the first and the second rule. So let's quickly move over to the third rule. I said we'll be learning several rules in order to be able to determine the oxidation number of elements in a given compound or ions or radicals. Now let's quickly move over to rule number 3. Rule number 3 says the oxidation number of oxygen in most compounds is -1. So the rule is the oxidation number of oxygen. You have to take note of this. The oxidation number of oxygen in most compounds containing oxygen is -2. While the oxidation number of same oxygen in peroxides is -1. Now let's take an example, e.g. that's example. Now let's say we are having a compound containing oxygen, and that compound is water, H2O. This compound is containing oxygen. It is water, a very, very common compound. So what becomes the oxidation number of oxygen from my explanation? Is it -1 or -2? Because this compound is a very common compound. So the oxidation number of oxygen in most compounds is -2. So for we to have a peroxide, we will add oxygen to this. So let's say we are having H2O2. What becomes the oxidation number of oxygen in this particular compound, which is a peroxide? This compound is a oxide, okay, because there's addition of oxygen. Okay, here was one atom of oxygen, here is now two atoms of oxygen forming a molecule of oxygen. So oxidation number of oxygen here becomes -1. Okay, that is what we are trying to say with this particular rule. So you have to take note of this rule. It is very, very important. So let's take another example. This is another compound which is a peroxide, K2O2. It is the peroxide, which is called potassium peroxide. Okay, this is potassium peroxide. What becomes the oxidation number of oxygen here? It is -1. And another compound, CaO2. Okay, this is actually peroxide. Okay, you can say I did not put 2 here because the oxidation number of oxygen here is -1 still. Okay, this is a peroxide called calcium peroxide. You know, whenever you just add oxygen to the compound or another atom of oxygen, you know, that particular compound is a peroxide. You know, the reason why it's not 2 here because this guy is a group 2 element of the periodic table called calcium. Okay, there are more explanations to this though, but you have to just take note. The overview of the oxidation number of oxygen in most compounds is -1, but in peroxide it is in most compounds is -2, but in peroxide it is -1. So let's quickly move over to the 4th rule. Now the rule says the oxidation number of hydrogen. All of these are very common elements which you can be asked questions, so you have to take note of them. So the oxidation number of hydrogen in most compounds is +1. But in binary hydrides, you know, binary hydrides are hydrides or compounds containing just 2 elements. Okay, binary 2 elements. So it can be like, but hydride talking about that the element which is more abundant is hydrogen. That's what's called an hydride, a compound containing hydrogen and another element, be it a metal or a non-metal. When you want to be specific, you call it a covalent hydride and also an ionic hydride. Okay, that's for another video to be specific. So for this particular aspect, the oxidation number of hydrogen in most compounds is +1, but in binary hydrides is -1. This is a very, very important point you must take note of. A good example of binary hydride is calcium hydride. Okay, CaH2. Okay, calcium hydride. All of these must be noted though. Okay, so but most importantly, you have to take note of the first line, which is the oxidation number of hydrogen in most compounds is +1. So let's quickly move over to the next rule, because I'll be giving us 7 rules. So at the end, we'll solve a question that cut across all of the rules. Now let's quickly move over to the 5th rule. Now the rule says the oxidation number of fluorine is -1 in all compounds. This must be noted. You know, fluorine is an halogen, so and halogens are salt formers, so the oxidation number of fluorine in all compounds is -1. Now let's quickly move over to the last most important rules. Okay, the last 2 most important rules. Now the first of them is this: the algebraic sum of all elements in a compound is 0. So what am I trying to say? It means that the oxidation number of the algebraic sum of all elements in a compound is 0. So the oxidation number of the algebraic sum of all elements in a given compound is 0. Now this is what I mean. For instance, we are having a compound which is H2SO4. What becomes the oxidation number of this compound? It is 0. So it means that when we want to determine the oxidation number of a particular element in this compound, we always equate the compound to be 0. So it becomes H2SO4 is equal to 0. So the algebraic sum of all elements in a given compound, the oxidation number is 0. This must be noted. Okay, now let's quickly move over to the last rule. Now the rule says the algebraic sum of all elements making up a radical is the charge of that radical. is the charge of that radical. So what am I trying to say of that radical? Now, first of all, what is a radical? A radical is simply group of atoms behaving as a single charge unit. So this is a good example of a radical. Carbon is an atom. Oxygen is an atom. Oxygen is an atom. Now, how many atoms of oxygen here? 3. And now these particular atoms, they bear a single charge, and that charge is -2, or you say 2 minus. Okay? And that charge is -2, or you say 2 minus. Now, when we condense this compound, we are having something like this. CO3 2 minus. This is a radical, and this radical is called the carbonate radical. Okay, it is called the carbonate radical. So what am I trying to say? It means that the oxidation number of the algebraic sum of all elements making up a radical is the charge of that radical. So what becomes the oxidation number of this radical? It is the charge of the radical, which is -2. So the oxidation number becomes -2. That is how it is done. So you have to take note of these last two important rules. They are very, very important. So now, let us solve a particular question that cut across all of the rules. It is very, very important you watch this video till the end so you get all the important informations of this video. So let's quickly solve a question that cut across every rules written on the board. Now, let's quickly move over to the practice question. Now, the question says, what is the oxidation number of sulfur in the following species? These are the questions. These are what we are to look for. The oxidation number of sulfur in each of the following species, be it a compound or an element or a radical, okay, as seen in the rules. So for A, that's A is S8. So from explanation, this is a free element. The oxidation number of all free elements is 0. So it means that the oxidation number of sulfur here, the oxidation number of sulfur, okay, in S8 is equal to 0. Okay, so that is for that. So for B, this is a compound, SO2. And recall, the question we are asked to determine the oxidation number of sulfur. So this is what we are looking for. And there is a rule I said that the algebraic sum of all elements in a given compound is 0. That means the oxidation number of the algebraic sum of all elements in a given compound is 0. So this is what I should write next. So SO2, we are looking for sulfur. So the algebraic sum of all elements in this compound is 0. So we can have an equation so we can solve. So this is sulfur which we are looking for. So, and this is oxygen. Recall, I said that the oxidation number of oxygen in most compounds is -2, but in peroxide is -1. This is a very common compound, so it will be that of -2. Okay, for the peroxide is red though. Okay, but you have to take note of these particular ones. Now let's quickly solve this question now. So we are looking for sulfur. So the next thing to write is plus. Plus is what separates the two elements. So after writing what you're looking for, which is X plus the oxidation number of oxygen in most compound, which is -2. So after writing plus, you put your bracket -2. Now, how many atoms of oxygen can you see here? 2 atoms. So I simply times 2, close the bracket, is equal to 0. So S, which I'm looking for, plus -2 times 4, that is -4, is equal to 0. So what becomes the next step? Plus times minus, that is minus. So it becomes S minus 4 is equal to 0 because plus times minus is minus. So making S subject of formula, so S will now be equal to, when you move this -4 to the other side, it becomes +4. So what becomes the oxidation number of sulfur in this compound? It is +4. So you can see how questions like this are being tackled. So let's quickly move over to C, or I'll leave this for you to solve. So I'll proceed to D. So you solve this and provide the answer in the comment section below. So let's quickly move over to D. This is H2SO4, and the question is asking us to determine the oxidation number of sulfur. Very easy. What is the oxidation number of hydrogen in most compound? It is +1. And what is the oxidation number of oxygen in most compound? It is -2. And what is the algebraic sum of the oxidation number of all elements making up a compound? It is 0. So first of all, we have to equate it to 0. So H2SO4 is equal to 0. Okay. After doing that, we simply start imputing our oxidation number. So for hydrogen, which is +1, how many atoms of hydrogen? 2, so times 2, plus sulfur, which we are looking for, plus oxygen in most compounds -2 with your bracket, and how many atoms? Times 4 is equal to 0. Okay, so next will now be +1 times 2, that's +2, plus S, which is sulfur we are looking for. Now, -2 times 4, that is plus into -8. Close your bracket. Okay, -2 times 4 is -8. So +2 plus S, which we are looking for, plus times minus, that is -8, is equal to 0. So what becomes the next step? We make S subject of formula. So you make sulfur subject of formula. S, which is sulfur subject of formula. So subject. So S will now be equal to -8 crosses the equality sign, becomes +8. So +8 minus +2 crosses the equality sign, called -2. So S will now be equals to +8 minus 2, that is +6. So it means that the oxidation number of sulfur, okay, in H2SO4 is +6. Take note of that. So let's quickly move over to E. So for the E part, which is that of a radical SO4 2-. So how do we determine this? Very easy. First of all, this is a radical. It is not just a compound. So will I equate it to 0 or equate it to the charge of the radical? I equate it to the charge of the radical from the last row. So we are looking for sulfur plus, or before we even do that, so it becomes SO4 2- is equal to the charge of the radical. Now the next step is to simply start imputing your oxidation number of the other element here, which is oxygen. So sulfur plus oxygen oxidation number is -2. How many atoms? 4. That's times 4. Close the bracket. These two will not affect it anymore. Is equal to -2, which is the overall oxidation number of the radical. So we've gotten the expression. So X, which is what we are looking for, plus -2 times 4, that is -8, is equal to -2. What happens next is S minus 8 is equal to -2, because plus times minus is -8, minus, so -8. So here is -2. After that, S will now be equal to move -8 to the other side, become +8 -2. So S now becomes to +6. So you can see how questions like this are being tackled. So you do well to solve for F, and you do well to solve for this other one, which is C. So you solve and provide the answer in the comment section below. So if you like this video, do well to hit the subscribe button and also share these videos with your friends. Thank you very much, and God bless you.